Okay, so in this class we'll discuss this test portion 6.3C. okay, this question is class 10 maths, page 146. You go there. Okay, so let us start with B2. So as we look into the question, we have a figure like this. So let us draw that, and there are two lines cutting, one from here and another one from here. In this kind of a manner they are cutting, and the best line is being drawn. Okay, so here is A, O, B, and then here will be your C, and here D. This is given as 125 degree, and this angle here is given as 70 degree. Let us write down what is given in the question. So given to us is here in the figure, triangle ODC is similar to triangle BOC. This is already given. This ODC is similar to OBA. It is very important that the position of these letters are correct. Okay, so therefore we have to look carefully and write it. So here angle OBC is 125 degree. Then angle CDO is equal to 70 degree, and we have to find these angles DOC, DCO, and OAB. This angle measures we have to find out. So let us start here. One by one we can start. We can start with this, I think, DOC. So angle DOC plus BOC will be 180 degree, because these two make a linear pair, meaning their uncommon arms of these two angles make a straight line. So here this angle, the common arm is CO, is the arm of this angle, and this angle also has this CO as the common arm, and the uncommon arm of this first angle is DO, the other angle is OB. So the DO and BO, the uncommon arms of these two angles, is making a straight line. It's called linear pair, and when the two angles make a linear pair, their sum is 180 degree, right? So we know that. So that gives you here, here, let's do carefully. DOC, you can write as it is there. Go DOC as it is, maybe, and then plus BOC measure has been given here. I think this is not OBC but BOC, I think. Yes, make a slight correction. This is BOC. So 125 degree. This is 180 degree. Okay, you're getting right. Okay, so here angle DOC measure will be 180 degree, and plus 125 go to right side and minus 125 degree. So when you subtract these two, you're going to get equal to 55 degrees. So let us keep this one. So DOC found. Now let's try to find DCO. So DCO. So for that, in triangle ODC or DCO, whatever, this one ODC, this triangle, angle CDO, this one CDO, this 70 degree, plus angle DOC, this angle, and plus angle DCO, the one you want to find out, this one. These three angles inside the triangle will be equal to 180 degrees. You know this, right? because we know that sum of angles of any triangle is equal to always 180 degree. Sum of the three angles of the triangle. So that implies CDO, CDO, okay. So here CDO already given 70 degree in the question itself. DOC just now we got it here 55 degree plus DCO 180 degree because we know angle CDO is given in the question as 70 degree, and using equation number 1, which is giving you the value of DOC equal to 55 degree. See here, DOC equal to 55 degrees. So when you add these two, you're going to get 125 degree plus angle DCO equal to 180 degree. So that implies angle DCO will be 180 degree plus go that side minus 125 again, so you're getting 55 degree, equation number 2. So we have already found these two angles, so let's find this triangle OAB. So for that, let us do like this. We know that since triangle, this is given here, ODC is similar to triangle OBA as it is given in the question. So we write like that. So if two triangles are similar, then corresponding angles are equal. Two properties will follow. Okay, if two triangles are similar, first one is corresponding angles are equal, and second one is corresponding sides are proportional. I repeat, if two triangles are similar, corresponding angles will be equal, and the corresponding sides, second point, will be proportional. We don't need the sides, so corresponding angles means angle at the point O equal to first letter, second letter angle to second letter. So OAB means this one. So let us write here OAB, the angle at the vertex A, this one, in this triangle. OAB, which is in the third place, will be equal to the angle at the vertex C, third place. Third place angle is called corresponding angle. So in the other triangle, the angle here is DCO, angle DCO. So we write like this. So here this angle DCO at the third vertex, third position point of the triangle, first one, equal to third and third, that is corresponding OAB. Reason is because we know just now, as we said, corresponding angles of similar triangles are always equal to each other. Likewise here, angle at O and angle at O equal, D and B equal, but we don't need those two, so we didn't write it. Okay, so here this one, so that implies DCO, just now you found it out, 55 degrees, so replace it by 55 degree equal to OAB, since using equation number 2. So you can put this one as 3. Then finally we can write our answers. You can write it like this. Below this one you write it, therefore angle DOC here just now, this one 55 degree, as you get this one by using equation number 1. Sorry, number 1. And DCO equation number 2, so 55 degree again, since using equation number 2. OAB also just now equal to 55, and we write that one by since using equation number 3. So these are the 3 answers. You write like this below this. Okay, so here once you're through with that, we'll go to the next question, B3. So here, let me read the question for us. Diagonals AC and BD of trapezium ABCD with AB parallel to DC intersect each other at a point O. So let's draw the diagram. Trapezium means one pair of opposite sides in a four-sided figure are parallel. These two are parallel means A, B, C, D. So if up and down opposite, right side BC and left side AD are opposite, the other opposite side may not be parallel, but at least one pair of opposite side must be parallel in a trapezium. That's called a trapezium. So we write there given. Let's do this slowly. Given to us as we read question is diagonals AC and BD of trapezium, in short you can write like that, A, B, C, D with AB parallel to DC. They're writing CD, DC is same. Okay, so DC intersect means the diagonals intersect, means cut each other at the point O. Diagonal means vertex A and C, which is far away. Sharp points are called vertex. So vertex A and B are nearby, so consecutive. But the non-consecutive line joining non-consecutive is called diagonal. So there are two diagonals possible. They intersect at O. So you have to show that. So you have to prove that here OA by OC is equal to OB by OD. This is what we have to prove. Okay, so let us start. So proof means answer for this. Proof. So let us take like this. AB. Okay, let me just start with this. Okay, AB parallel to DC because it is given. So if these two lines are parallel, then this angle here, let us mark 1, this one 2, cut by this transversal SC, then see here Z kind of a letter. Inside on the right, inside on the left, alternate will be equal because we know alternate angles are always equal when the lines are parallel, right? So now next here I will write here 2 equal to 3, angle 2 equal to angle 3, because we know they are vertically opposite angles. Equation number 2. When two lines cut, this one or this one vertically opposite are equal. 2 and 3. See here, these two lines straight cutting, so up and down like scissor angle 2 and 3. Then here 4 if I put, and here 5. Then I write here angle 4 will be equal to angle 5 because they are again alternate angles. The lines are already parallel. This line parallel to this, so if you cut this, then 4 inside left, inside right, they are alternate. Let's put this one as equation number 3. So now here, using equations 1, 2, 3, what do you observe? That the angle 1 inside this triangle AOB equal to angle 2 inside DOC, 2 inside AOB equal to 3 inside DOC, 4 inside AOB equal to 5 inside the triangle DOC. So in these two triangles, up and down, AOB and DOC, all the three angles are equal. So the triangle will be similar. You can follow this vertex 1, 2, 3. So one vertex is A, two vertex is O, third 2 and 4 vertex is B will be similar to. So you have to follow the same order 2, 3, 5. So 2 1 equal to 2. Oh, we made a mistake, sorry. Here 1 equal to 2. This should be 3 equal to 4. Okay, just like correction. 3 equal to 4, correct it. So this would be, because 2 is repeated, 3 equal to 4 and 5 equal to 6, sorry, 5 equal to 6, next slide correction. So this should be 5 equal to 6. So here A or B following 1, 3, 5. So A, 3 here, O, 5 angle at the point B, so A or B. Similarly 2, 4, 6 order you have to follow. So 2, C, 4, O, D. So C, O, D, and reason is because we're using AAA Similarity Criterion. That is, if in two triangles, 3 angles in the first triangle are equal to 3 angles in the second triangle, then 2 triangles are similar, right? So if 2 triangles are similar, we have been saying this just in the previous numerical also, the corresponding angles will be equal. Number 2, corresponding sides will be proportional. That's what we need now. Second one, corresponding sides means first 2 letters, the side formed by the first 2 letters in the first triangle means the first 2 letters. What are they? Yes, that's right, CO. So first two letter is the corresponding side ratio. Second and third, OB. Here second and third, that's right, OD. First and third, AB. There in the second triangle, first and third letters, English letters, CDS. So that is called corresponding side. So first ratio means division of the sides side by side. Division of same type, that's called a ratio. These ratios are equal is called proportional. So these 3 sides ratio will be equal if the triangles are similar. They are already similar established. So we write this and we give the reason here, since corresponding sides of similar triangles are proportional to each other. Then we take out the 2 ratio that we need to prove your OA, OC, the first one here. AO, OA is same, okay. AO, OA, first 2 letters should be there, but order is up to you. Then OC, just writing like this. Your OB, second one, by OD. So we need these 2, so we take this and just leave out the third. We have proved, right? That's how we do. Okay, so next B4. B4. Let me read the question. In this figure, like this. So let's just draw the figure first. Something like this is there. A line is here. And then here a line is joined. This is given as angle 2. This is given as angle 1. Q, R, S, T, and P. Like that. So let's write down given in the figure QR by QS is equal to QT by PR, and angle 1 is equal to angle 2. We have to prove or to show basically triangle PQS similar to triangle TQR. Okay, so how do we do this? Let's prove it. Proof is here. Now let us take this triangle here, PQR. Let me trace it once for your sake. This one, PQR. So in triangle PQR, here we see angle 1 inside this triangle PQR is equal to angle 2, which is also inside PQRC. PQR, this angle PRQ, which is mentioned as 2, because it is already given in the question, right? So there is a theorem which says if in any triangle two angles are equal, like here 1 and 2 are equal, the sides opposite to them will be also equal. So here, what is the side opposite to angle 1? Find out the arms of angle 1, because every angle has 2 arms, like we have 2 arms. So inside this PQR, QR and QP make angle 1. So which side of this triangle do not make this angle? Yes, that's right, PR. Let's call the opposite side opposite to angle 1. So find out the side opposite to angle 2 likewise. The 2 arms of angle 2 are RP, yes, and the other one? That's right, RQ. Which one is not? Yes, PQ. So PQ is the side opposite to angle 2 in this triangle, and PR is the side opposite to angle 1 in this triangle. These two will be equal because the angles are equal. So we write here the theorem. Since we know that sides opposite to equal angles in any triangle or in a triangle are always equal in measurement, means 5 centimeter and 5 centimeter. Let's keep this one because we're going to need it in the proving of these two similar. Okay, now let us write down here this one, QR by QS is equal to QT by PR, since it is given to us. We can use it like this, but I just want to go like this, QT by PR. You can write first also, and then this one QR by QS, same thing only. You can directly use the above one also. Okay, now find the angle between these two here, QT and QR. QT and QR, the angle between those two sides QT and QR is angle 1. And then between this, before that, let us write down, before we go one more step, QT by PR. So here, PR, QT by PR, PQ. Okay, so PR can be replaced by PQ. So you replace this PR by PQ equal to QR by Q, since using equation number there 1, you see here, PR equal to PQ means PR can be replaced by PQ. Now find the angle between these two sides, QT, QR. QT and QR is angle 1. Then what is the angle between PQ and QS? PQ and QS, same angle. So they are equal because they happen to be the common same angle. So let us put this one as 1 and this one as 2. So using equations 1 and 2, we remember there are 4 similarity condition: AAA, AA, SSS and SAS. Which one is it? Now look here. This here, QT and QR are the side of one triangle, QT, QR. QT, QR are the side of this big triangle. PQ, QS, PQ and QS the side of this small triangle, PQS. As you can see here, two sides are proportional. So, and the angle between the two sides, QT, QR, angle 1, PQ, QS, angle 1, are equal. If two sides are proportional and the angle between or included between the two sides are equal, then the triangles are similar by SAS. So here, let us go like this, PQ. So since the start of the small triangle, let us go denominator first, PQS. PQ, QS are the triangle. PQ and QS are the sides of this small triangle, PQS. So going like this direction means PQS. So PQ first and S, so I write here triangle PQS. If you go like that, you have to follow the same style for the upper one. You went from here to here. So you should not go from here to here. You should go from just like left to right, left to right. So QT, QR. For the big one, QT, QR means you have to go not RQT but TQT first. So TQ, QT, TQ is same, TQR. So TQR, and you go to see same order. And we know this is similar because by SAS, since using SAS similarity condition of triangles. Okay, this is how we do. Okay, so once we're through, see here the two sides QT and QR of this triangle PQS, QT and QT and QR of this triangle, PQ and QS of this triangle, PQ and QS of this triangle, and the angle between them. And here QT, QR of the big triangle, QT, QR of the big triangle, between them angle 1. So two sides and the angle between the two sides are equal, means the triangles are surely similar by SAS similarity, right? So that's it. One more question before we end this test portion. Let's go and do it. B5. Let me read the question for us. ST are points on PR and QR of triangle PQR. The diagram is not given, so we have to draw ourselves. PQR is there, and S is on PR. So S is here, and T is second point, QR. So QR is the second side. T is here. Let us join it. Now, write the given information. S and T are points on sides PR and PQ of triangle PQR such that angle P is equal to angle RTS. Angle P here equal to RTS. So RTS means this angle are equal. See, so single dash I've denoted as equal. We don't need to, but makes it easy to observe. That's why I'm writing it. Now you have to prove that triangle RPQ similar to triangle RTS. Let's see how we're going to do this. As we said, there are 4 similarity conditions here. Which one is it we're going to use? AAA, AA, SSS, and SAS. So let us prove. Maybe here itself, because there is space now. I think enough. Now I'm going to write like this, okay? So P, R, PQ, R, PQ. Okay, they're taking the bigger one first. So the angle R equal to angle R, you would agree with this, since it is common. Okay, so let us keep this one as equation number 1. Then here, next one, angle RTS. Angle, or no, they're taking bigger one first, RPQR, PQ bigger one, and RTS, smaller one second. Okay, so let's go in the same order. P of the big one. Okay, P of RQP equal to this one, angle RTS. As you can see here, since it is given. Look at these two triangles and compare with this. So using equations 1 and 2, take this RQP bigger one, and RPQ is bigger one, RTS. Now this angle inside this big triangle RPQ is equal to angle R in the small triangle RTS. Then next, angle P in the big triangle equal to RTS. So RTS. So P is second position, T should be second position. So here, similar to triangle, R. Then here, T and P are the equal points. So T should be second point. P is second point, means middle point. T should be second point. And then the third letter is this one. So see, they are similar because two angles R and P inside this big triangle equal to R and angle RTS inside this triangle. Then you will know that even only two angles are equal also. These triangles are similar. So we're using AA similarity condition. See here, this one. So we've proved. Right. So this concludes the portion. You can go and give the test. This test is the same question. You go study carefully, and if you have understood properly, you take the textbook and just solve the same questions, B2, 3, 4, 5, without any help, and then submit for correction. Okay. So that's it.